We are creating a bridge between two communities of people that have a lot in common, but they're also very different. Where they are, what they do, and where they move. And these two communities, through this project, are able to start talking.
What Matters is a project matching together designers and material researchers to collaborate and experiment together and visualize the new materials that are being developed in southern Sweden. The idea was initially brought forward by one of the prominent designers in the region, Jenny Nordberg.
Working as a designer in the southern part of Sweden, you often hear about all the material research going on. But we as designers never see these materials. And we really want to know about all these new materials. I mean, we are very skilled in the traditional ones, but of course super interested in all kinds of new and innovative alternatives.
In January, we selected 10 different designers and matched them together with 10 researchers. And now they have 6 months to collaborate before handing in their results, their final objects for the exhibition in October.
Do you remember our first meeting? I said that I wanted to help you in your work, like pick my brain, use my creativity. And you had different kinds of expectations. You wanted something traditional, artsy.
Yeah, I actually forgot that.
Yeah.
But you're right. So we had different starting points there, which we pretty soon sorted out, I think, to find a common path.
Yeah. Magnus and I have worked around the bone healing process, which is Magnus. He's a professional bone healer.
I always thought that bone was a very beautiful thing, so I was very happy that somebody appreciated the aesthetical part of bone.
That was sort of our starting point. And then this very long email conversation took a couple of months, I would say. But in the end, well, I sort of decided on this in vitro printer, which is a bone-influenced 3D printer, one could say. And this interacts with the bone?
Yes. So what we then do, we inject this stuff on the inside.
I mean, this 3D printer technology is here to stay. We're going to make organs, and the easiest organ to make is bone. So I think we're not very far away from what we are sketching here.
Can you take a picture of this?
Absolutely. So this is the material we're talking about, mixture of everything.
Yeah, exactly.
The biggest challenge was definitely that we were dealing with a material that you can't see with your bare eyes. A nanometer is a billionth of a meter. And just to think about it makes you crazy. You can't see it. For a human, it's invisible. So we asked us, how can we make the invisible visible?
Entering the lab was a very symbolic way to describe the scale. Like the scale they are working on, and compared to the scale we are working on, we are not worried to lose a skin cell.
In the lab we need to keep it very clean, because small structures that we work with, they are smaller than a lot of the pollutants in air. So the clean room environment that we work in is heavily controlled. This is where we grow nanowires. First, the nanowire starts from making it, that we call growing a nanowire. So typically we start with a flat surface, we call it a substrate, and we put gold particles on it. and then we put this substrate into a growth reactor and then increase the temperature, and then you introduce gases, so that's your material. And then we can grow these materials under these gold particles atom by atom. And after the nanowires are grown, of course we cannot see them, so we need to use a lot of tools in order to characterize their properties. So we'll go look at the electron microscope, for example, where we can really see the structure, the shape, how long they are, how fat they are, things like that. So this is at 2000, so you can see that something is there.
It's just like they're alive.
There is a lot of promise for nanowires and the benefits they could give for lots of various applications, going from electronics to optics and solar energy and lasers and so on. But at the moment, there has not been yet, as far as I'm aware, applications out in the world that you can buy.
Kind of quickly, as we always do, jump on 3D software where we are comfortable in sketching and trying our ideas out.
We can create something fun there when it's suddenly so far away.
So we did some form studies. What do we see when we create this array of rods?
It's 1 billion times larger than the nanowires we saw in your pictures.
We want to create awareness about renewable energy, using free energy, which is all around us, and we're focusing on heat energy, which will basically be this object's purpose to regulate heat.
It's basically a radiator.
In this project, I think we took the direction of heat, the nanowires. I guess again it's more the surface property, that it's a lot of surface that it can interact with.
Every year in Malmö they have the Malmö Festival. As part of that process they also have the big crayfish party. So we rocked up to this crayfish party and it was really interesting. Every single family and group of friends got together, they laid out their dishes and they all put on crazy bibs and crayfish inspired accessories. But what was really sad was to see how all of this crayfish was being thrown into the bin. As a person naturally curious, and I'm aware that obviously, you know, certain things in nature have valuable materials, I was quite curious as to what this material could be.
First, when we got paired, we had a meeting. We start to talk, we communicate, and then she came with, oh, I have this project, and is it possible to do this in the lab? And so, of course, it's just what I'm doing. I'm working with downstream process, and that means purification and separation of the compound, molecule, protein. The shell itself consists of polymer, which is chitin that we are using. The polymer itself, it can be valuable in terms of nowadays everyone is talking about plastics and pollution we are getting from the synthetic plastic. And chitin can replace plastic because it's biodegradable. There are so many possibilities. The bottleneck is the extraction, all the things you need to go through the process to scale it up. Each of these curves, they have a meaning. Okay. For instance, this can be amino groups. Here we normally can see water.
For me, what was most interesting was obviously the dialogue, first and foremost, having that conversation and Salma's kindly, you know, really making it digestible for me to understand what was going on. And just hearing about her research was really fascinating, but also useful to see the extraction process. So how does that actually work? Wow. The difference is, I think, probably someone else does a lot more research and understands how to do that first, whereas I do just chuck things in a cup and see what happens. And if nothing then happens, then I will research into it.
So these are the samples that I've been working on.
And I don't have the most methodical approach, so having that kind of experience has kind of made me take that into account as well.
Combining two very different areas like this is a really good thing. They can learn so much from each other, and you need to have a discussion to even get a starting point or to get anywhere. And I think that's just a great experience.
One of the challenges with this kind of collaboration is the language. We don't share the same vocabulary. I remember that I resembled the bone healing process as it's almost kind of magnetic, I said to you, and you were just like, no, it's not magnetic. No, I didn't mean that it was magnetic, but it's similar. And you were just there. I thought, that, yeah, he's really on the other side, like right and wrong. No, this, yes, no. You understand?
No.
But I think that we have learned from each other throughout the process how you work, how I work, how we need to communicate.
I went into, obviously, this situation in some ways with assumptions, you know, this very narrow assumption that, yes, let's extract this waste material. But then, in actual fact, when you look at this project from a realistic perspective, where you're actually in the lab trying to do this, it really brings you back to earth and makes you think, if I really wanted to do this and take that to that next level, then I need to, you know, work and collaborate with scientists and to establish that kind of dialogue and relationship so that I can actually bring this into the real context.
I think it's kind of nice to be with someone that is so much better than you in a specific area. I mean, you're the professional in that, and that in a way makes me more comfortable in my situation as well. Okay, then I have to be the designer. And you also get challenged in your own position in a very nice way. You have to prove what your skills are.
It's a much greater challenge than anyone can understand to start working over borders like this. And with that question of if we repeat this collaboration, will it be easier in the future? Absolutely yes, because then you have something to start from. You don't have to go through this process. The next project will be much easier because you understand each other.
It's not that different, really. The designers and the scientists, I think both are very self-motivated and very driven, passionate about their work, and they want to make something that makes an impact to society, and a lot of creativity because you work with things that don't exist. So I think it's a lot of similarities, it's just the technical basis is very different. It's been a wonderful experience, and I'm really looking forward to see the final product.
In terms of the end results, I think personally, and I think we all are very excited to see what happens, you know, because have kept it so open, precisely because we want to see what comes up. Is it going to be a new material that is in the lab used in a complete different way? Is it going to be something that explains science in a more tangible way? We don't know, and that's why this exhibition, I think, is going to be very interesting.
You need to imagine something. You need to have a dream, even as a scientist. If you don't have the knowledge, you can always collaborate. And this is what this project is about, collaborating with different people. It's cross-disciplinary, interdisciplinary, because people are aware of their limits. And then they need to go and talk and find out, okay, that scientist, that mechanic, that designer, I can use them, they can use me. We can just bring all our knowledge to one big project and make something. And I think that's the whole beauty of it.